Hello everyone. In the last video, we covered inventory models and systems that align with various operational assumptions. Today, we will delve deeper into the details of inventory models. To effectively understand and implement an order model, it's essential to grasp the following key concepts: economic order quantity, reorder point, and safety stock. The optimal order quantity for a company is one that satisfies demand while minimizing the total costs of ordering, receiving, and holding inventory. Therefore, we need to understand the costs involved in bringing a part from a supplier through business processes to the customer. The total annual cost consists of the purchase, ordering, and holding costs. This chart provides a visual representation of how different order quantities affect the total cost, helping businesses make informed decisions about their inventory management. The intersection of the ordering and holding cost curves determines the EIC, where the sum of these costs is minimized. By ordering the EIC, a business can minimize the total inventory costs, balancing between ordering too frequently, high ordering costs, and ordering too many units at once, high holding costs. Determining the reorder point is the next step after finalizing the EIC. In an ideal world, you would never need to use your safety stock. However, this scenario is highly unlikely. Safety stock exists to protect you during periods of demand and lead time variability. It helps mitigate lead time issues and minimizes the impact on your service rate. Dealing with uncertainties and multiple variables, the best way to calculate safety stock is to use standard deviation to determine variations in supply and demand. The formula for calculating safety stock is given by the equation. Z is the desired service level, sigma LT is the standard deviation of lead time. D average is the demand average. Ensuring that you have safety stock seems advantageous, but it's important to be aware of the risks involved. Over-optimizing stock levels isn't always the best approach. Here are 4 common risks related to safety stock that you need to consider and incorporate into your safety stock calculation. A common mistake in supply chain management is setting safety stock to 0 with the aim of reducing inventory levels and on-hand stock. While this approach does achieve those goals, it also significantly lowers service levels, often resulting in higher costs than maintaining extra inventory. Different industries have unique factors impacting their supply chain and safety stock needs. While common formulas can be used as a starting point, they must be adjusted for specific factors like upstream failures, reorder periods, and order quantity requirements. Safety stock addresses variability in the supply chain and demand, not just lead times. Reducing safety stock solely because supplier lead times have shortened is a mistake. Instead, always consider the standard deviation in lead times. For instance, if a supplier's lead time is 5 days with a standard deviation of 2 days, maintain 2 days worth of safety stock. Stockouts are inevitable, despite efforts to prevent them. Safety stock is intended to prevent most, but not all, stockouts. Calculating safety stock involves maintaining a service level, which requires balancing inventory holding costs and service levels. Striving for a 100% service level, meaning always having stock, is risky and often impractical due to variable demand. Other than the safety stock formula I mentioned, there are other formulas to avoid these risks. The basic stock formula is the traditional method, which simply add the number of days of stock on top of the demand. The second method is average max. This method is commonly used but can be challenging if you have a particularly long lead time. Essentially, the goal is to calculate the average maximum units needed at any given time. The third method is suitable for situations where demand fluctuates, but lead time remains relatively stable. If you find there is a significant uncertainty in both demand and lead time, as they operate independently of each other, you can use the fourth method. For situations where demand and lead time are interconnected, you might consider using this final formula. Here are some advice for choosing a right safety stock calculation. For a company with low sales volumes of 100 units or less, we recommend using the average max method. If the sales is between 100 and 300, it's best to use the fifth method. For any businesses facing a high degree of uncertainty, the third method would be more suitable. No matter which formula you choose for your safety stock, it's crucial to consider the quality and quantity of your data. Since having a solid and reliable data set is essential. Otherwise, your calculations could be inaccurate, potentially causing more troubles than they solve. Thank you for watching our presentation on safety stock management. Effective inventory control is essential for minimizing stockouts, satisfying customers, and boosting profitability. By using the right safety stock strategies, tailored to your business's unique needs, you can achieve greater efficiency and better financial performance. Remember, accurate data and a strategic approach are key to success. If you have any questions or want to learn more, please reach out. Let's work together to optimize your inventory management and drive success. See you next time.